Recording in progress. Hello, everyone. I wanted to record a video to cover the content that we covered in class today. And so here, I'm going to share my screen. So today we covered a lot of content. We covered right, how to open RStudio, how to create an R project, and open an R script. In this video, I'll just be covering the kind of coding part that we covered. And so we learned basic arithmetic. So we learned that we can use R for calculations. So for example, this 1 plus 5, if I run that on the bottom, here you see 1 plus 5, it gives me 6, right? Subtraction, 1 minus 10 gives me -9, 5 times 10 gives me 50, and 10 divided by 5 gives me 2. And so we learned that with R code, we can use it as a calculator. R is a calculator. We also learned that we can assign numbers into objects. So you can see here with this arrow, which is the less than sign, minus sign symbol. We save 10 into A. And we can see here that A shows up on the left. We have a 10 for the number A. And we can use that A as if it was 10. So say A plus 5 gives us 15. A divided by 2 gives us 5, right? 10 divided by 2 gives us 5. You can see that on the bottom. We learned how to create vectors using the C function. So the C function combines things together. So you can see here, we took all the ages in the class and we created a vector called ages. And so we can take the sum of all our ages. So the sum function takes a numeric vector and we'll add everything together. So if we take all these numbers and add them up, we get 122. The mean function takes the average. So the average of ages gives us, right, 20. So the average age was around 20. The table function, right, given a vector, it will tabulate or count how many unique instances there are. So we can see here there's one 17-year-old, 3 20-year-olds, one 22-year-old, and one 23-year-old. And so to clarify, this is a function, right? So function has like a special keyword and then these two parentheses, and the input goes inside that parentheses, and there's some output. And so this function outputted the sum of all of the elements and ages. This function, the input was all the numbers and the output was the average. This function, the table function, the ages, it counted how many unique ages there were. We also talked about text data. So text data is represented in quotation marks. So you can see a quote, hello, it outputs the text hello. And that's different. That is different from just typing out the word hello. If I type out the word hello, it's going to give me an error. So see on the bottom, error, object, hello, not found. And so because hello with no quotes is trying to look for an object named hello, which we don't have. So it's an error. We can assign an object. So here we have my name, Victor, capital V Victor, and I'm assigning it into the first name object. And so this first name object, if I type it into the console here, contains the word Victor, and it's in quotes. And we can use the functions on this object, first name. So here's the toUpper function, which will make all the letters uppercase. So I'm going to feed it my first name. And I see the output here is capital Victor, all caps. The toLower function makes everything lowercase. So you can see that my capital V before and first name became a lowercase v, Victor. And that text and numbers are treated differently in R, and it's important to know which is which. So in this example, we have 10 in quotes, which is a character, which is its text, and then we have 10 that doesn't have quotes, which is treated as a number. And so if we try to add text 10 plus regular 10, we get an error because we get a non-numeric argument. So 10 in quotes is not a number. And so it's because it's in quotes, it's considered text. So we got introduced to data types. So we learned, right? So that we saw something in quotes is considered a character. Something that doesn't have quotes and is a number is considered numeric. So there's functions called isCharacter. So my first name, Victor, that was in quotes. If I use the isCharacter function, so this function asks the question, is the first name object a character? And when I run that, I see true. When if I ask the question is numeric, right? So if we remember the A object from before was 10. So we can see here 10, A is numeric. We're asking, is it a number? We get true. So we can also use the str function to examine what is an object's structure. Like what is it? This str stands for structure. So if we use str on first name, we can see the chr, which stands for character. And then we can see what it is, which is my name, Victor, in quotes. So we can look at the structure of A, and we see that it's a numeric, NUM, numeric, and then it's the number 10. So characters, numbers are different things in R, and characters are always in quotes, and numbers are always numbers. And if a number is in quotes, it's considered a character. So we also learned a little bit about comparisons. So this is simple logic. So we learned that we can use the less than sign, greater than sign, equal sign to kind of ask questions of data of our objects. So say we have the A, right? A is the number 10. If we ask, is A greater than 10? We get false. So false says, right, that's not true. 10 is not greater than 10. We learned the equal sign is to ask the question, are these two things equal? And so we use two equal signs here because we're not saying A equals 10. We're asking, does A equal 10? And so you need two equal sign there. And we say true. We get a true because A equals 10 equals true. A greater than or equal to, so when we put them together, the greater sign symbol and the equal sign, we're asking, is it greater than or equal to 10? And that'll also be true because 10 is greater than or equal to 10. So we can see here, we can do the same thing with text data. So I have my first name object. I can ask it, is it equal to capital V Victor? It's true. We can also ask it, is it equal to lowercase v Victor? We get false. So this is the idea that R is case sensitive. So capital V Victor is different from lowercase v Victor. If we wanted this to be true, then we would first have to take my capital V Victor and feed it to the two lower functions. So two lower will make everything lowercase. And then we ask it, is it equal to Victor, lowercase Victor? And we see that that's true, right? Lowercase first name, Victor, is equal to lowercase Victor. And so these values, true, capital TRUE and capital FALSE, is another special data type. So we talked about numbers, numeric. We talked about characters. True, capital TRUE and capital FALSE, capital trues and false, are logic values. And so they're separate from numeric and text. They're logic. So you can see here, true, I'm going to save it into this object logic true. And then if I look at the structure of logic true, I see that it's a logic value. So it's a type logic. So before we saw type character and type numeric, and this is a type logic. So the isLogical function will ask the question, is this logical? Is this a thing, the input logic? Is it a logic value? So you can see isLogical true. So I'm asking, is true a logical value? We get true. If I say isLogical false, I'll get true because false is illogical. If I check to see if the word true is logical, I'll get false because the word true is not illogical. The word true is a character. So after that, we learned how to index vectors and subsequently data frames. And so, right, if we look at our ages, right, our ages is a collection of numbers of all our ages in class. And if we want to index or grab one of those ages outside of the vector, we use these square brackets. So the square brackets after the object, and then we put numbers inside that square bracket to say, what do we want to grab? So we can see here the number 5. If we put the number 5 in the square brackets, we get the number 20 because that's the 5th item. So 1, 2, 3, 4, 5. 5th item is 20. If we put in the number 1, that grabs the first item. So we can see here 23 is the first item in ages, and that the ages square brackets 1 grabs 23. We can also grab multiple things at the same time by, instead of putting just one number in the square brackets, we can put multiple numbers in the square brackets. So here I'm using the C function to make a vector of 1, 2, 5. So if I don't put the C there and I just put in 1, 2, 5, it's not going to work. C gives it a vector. Let's say it's a collection of these things. I get 23, 22, and 20. So I grab the first item, the second item, and the 5th item. So we can grab multiple things at once. We also showed how we can use logic to filter things. So if I say ages equal to 20, I'm going to get false or true values for each item that meet for each condition. So for every age in ages, right, for 23, 22, 17, 20, 20, 20, we're going to ask the question, is it equal to 20? So for 23, that's false. For 22, that's false. 17, false. 20, true. 20, true. 20, true. And so we can use this logic, this vector now, where we ask the question, is each value 20? We can use that inside of the square brackets to grab the values that are true. So here I have the ages object, and I use the square brackets, and I put the logic vector, the vector that we asked for each element, is it 20? And that should grab me all the ages that are 20. 20, 20, 20. So next I asked for you guys to do an exercise, the vowels exercise. So in R, the letters object contains the lowercase letters of the entire alphabet. And so to filter out, to extract the letters in letters that are vowels, we created a vector of vowels. So here's C, right? For C is for creating vectors. And we did A, E, I, O, U inside that vector, and we called that vowels. We saved it as vowels. Then we asked, okay, for letters, for each letter, is it inside vowels? So it's going to go through A. It's going to check, is A inside the vowels vector? Is B inside the vowels vector? C inside the vowels vector, and so on for every single letter. So if we look at that, the logic values, logic vowels, we see we get a true, right? That's for A. B, C, D, E. E is true because E is a vowel. F, G, H, I. I is true because it's a vowel. J, K, L, M, N, O. O is a vowel, so it's true. P, Q, R, S, T, U. And U is a vowel. So you can see that true, the values of true are where in the vector there was a vowel. And so we can use that vector of logic. So we saved it here as logic _ vowels. And we use that in the square brackets. And that gives us all the vowels that are inside letters. I also brought up the concept of things being case sensitive. So capital V Victor and lowercase v Victor is not the same. So if I ask, hey, is capital V Victor the same as lowercase v Victor? I get a false because it's case sensitive. Capital, the letters have to be exactly the same for it to be equal to each other. I also took it a step further and introduced data frames indexing. So I use the iris object and I save it into data. And when we look at this, so I'm on the right in the environment, I see data and I see there's 150 observations with 5 variables. If I look at that in the panel, I can see here, this is how it's organized. I have rows and I have columns. And so each column is like its own vector. And so before we were just working with one vector, this data frame is a collection of 5 column vectors. And so we can index those columns and rows in the same way that we did before. But now we're working with a collection of vectors. So the way that we index, the way that we extract a value out of the data frame, right, is we use the square brackets, and there's the row value goes on the left and the column value goes on the right. So for example, this data, and in the square brackets I put 1, comma 2, will give me the first row and the second column. So that's 3.5. So if I take a look back to the data, so I'm back in the panel here, and if I look at the first row and the second column, 3.5 is the value. So this is very similar to the game Battleship, right? So you'll say like, oh, it's A1, and that's that square. B1, that's this square, right? But instead of A and B, it's either 1, 2, 3, 4, 5, or we can use the name of the column. So you can see I did this here, data, and then I leave a blank for row because I want all the rows. And I say quotes species. So this gives me, in my output here, this gives me the entire vector of all the species values in the data frame. So you can see here, this example, I have a blank space because I want all the rows of the first column. And so that gives me all the values in the first column. The names function, so I didn't talk about this in class, but the names function, if we give it a data frame, will tell us the names of the column names. So we can see here that these are the column names in the data frame. Okay, so we saw that this extracted all the values in species. So if we look at this, we see the 3 species are here, and these are all the values. If we feed this, the vector of all the species values, into the unique function, it will give us just the unique values in that vector. So we can see here when we do unique on the species vector, we get 3 values, which are the 3 unique species that are in the data. So when we are looking at we can do this. So before we were doing one row, all the rows, and looking at a particular column, we can do it in the reverse, where we say, give me the 10th row, all the columns. So we leave it blank, and that says all the columns. Second. So this 10 gives us the 10th row, all the columns. So we can see here the number 10 to indicate the 10th row, and all the values of the 10th row. So in all the columns. If we were to do the 10th row, second column, we get 3.1 because it's the second column. So this is the first column, second column, and it's row 10. So the value is 3.1. We can do the same thing we did before, where we can fit multiple values in the brackets. So you can see here the 10th row, and now see I'm asking for the first and the 4th column. And so I get 4.9 and 0.1. So you see this is the first column, and then 1, 2, 3, 4. This is the fourth column. And how I did that was I made a vector that had the numbers 1 and the numbers 4 in it using the C function, and I put that inside the brackets. And I get 4.9.1. So now we did the exercise in class where I asked to, in the data, right? This is the data. I want to only I want to extract all the rows that are Setosa species. And that's the species I'm interested in. And so the way we did that was we first got the species vector, which is the entire, all the values of species. Then we asked the question, equal to Setosa. And so this Setosa, is it equal to it? And so this creates a logic vector. So if we look at this logic vector, Setosa, we can see here we get falses and we get trues. And these true values are where the rows are equal to Setosa. And so we feed this into the rows. So we have our data and then we have our brackets. And so in the rows, we give it the logic of give me Setosa. And then I want all the columns. So give me the Setosa rows, and then the columns, I want all the columns. And so I filter the data and I'm going to save it as this Setosa data, as an object Setosa data. So if this Setosa data, it only includes Setosa observations. And to check it, I'm going to use the Setosa data, and then in brackets, I want all the rows, and I want the species column. And I want to put it inside the unique function. So you can see here, the unique of the Setosa data is just Setosa. And we successfully filtered or extracted only the observations that were Setosa. And that's everything we covered in class today. So thank you.